Okay guys, hello and welcome. So now we're going to look at the third thing. If you've been watching these in order, you'll have learned about sequence. The last one we looked at decision. Now we're going to look at iteration, or looping, or just making things happen over and over again. So same old story, we'll have the size of the screen set and we'll say 600 by 600, because that's the constraint for this week's lab. And what am I going to do? Let's draw a rectangle at position X, Y, and it's going to be 40 pixels by 40 pixels. Okay. So we'll bring in variables here as well. So I've got two variables. They're just spaces to store things, drawers, buckets, whatever you want to call them. And I'm just declaring them here as integer X and integer Y equal to 0. These names can be pretty much anything you like, and we use an equals operator to assign the value to them. So in this case I'm assigning the value of 0 to X, assigning the value of 0 to Y. The kind of boxes these are integer boxes, which is just whole numbers, so not decimals, nothing fancy. So if I draw a rectangle at 0, 0, 40 pixels by 40 pixels, in a screen that's 600 by 600, we should see a wee rectangle up in the upper left space. Okay, so what I want to do is I want to use a loop to draw this in different places and generate a pattern. So let's do this. There's a few ways we could do this. We could just repeat this, okay? So the simplest thing to do, I want one rectangle drawn there. I want another one at the same size drawn. I want X to be incremented or added to by 80, say, and I want Y to be incremented or added to by 80 as well. So let's just focus on this for a second. This thing here, I've got X, which is my variable. We know that the equals is for assigning a value, and you can probably intuitively guess that plus is for adding something. This is what's called a compound operator, where we mash together two features. So we're assigning a value of 80, but we're going to add that to the value that's already in this variable. So this is just a neat way of making your code a little more compact. So if I run this now, I should hopefully see two rectangles, one there and it's moved diagonally, which is fine. Close that. And if I wanted to do this lots, I could copy it, and paste it, paste it, and paste it. Okay. So I should now see a whole pile of rectangles moving diagonally across the screen. So that seems like one route of doing this. Okay, but let's imagine at this point I've actually decided that I'd like to change the value that I'm incrementing it, or I'd like to change the diameter. I'm going to have to change it in lots of places, and that's possibly a little bit frustrating. So let's see if there's an alternate route for doing this. So what we want is we want this sequence of event stuff, and we want multiple rectangles to be drawn. So we want the rectangle function to be called a number of times, and we want to be able to perturb or change the X and Y value so that it can be drawn in different places, because there's no point in just drawing it on top of itself. So in the simplest setting, we can use a for loop for this, a fixed loop for, and we'll just have a variable called I, which is our counter, while I is less than width, and I plus plus. And inside our for loop, so what's going to happen here, if I just describe that. So we've got a similar setup as we had before. We've got a keyword which tells us what this logical control structure is going to do, what the effect of it's going to be. We've got some regular brackets which tell us let us know how long it's going to happen for, and contain some other bits and pieces in the case of the for loop. And then we've got these curly brackets, which is the thing that's been looped, the thing that's going to happen over and over again. This is where it's contained. So in this case, I have set up an integer variable called I. I'm assigning the value of 0 to it. I want this for loop to keep on iterating while I is less than width, which we know will be 600, and I'm going to increment the steps of 1. Okay, so I is getting incremented by 1. Inside my for loop, I want to draw a rectangle at position X, Y, 40 pixels by 40 pixels. So if I ran this just now, I would just draw the same rectangle 600 times, 599 times rather, in the same position, which is not much fun. So what I'm going to do in the first case is x equals random width, because the x value is connected to the width of the screen and controls where we are in this dimension. And we need a semicolon after that. Y value is going to be equal to random height. So what's going to happen now is every time this for loop iterates, it's going to go and grab a random value somewhere in the range of the width, between the width and 0, and somewhere for the y value between the between 0 and the height, and that's where it's going to draw this rectangle. Okay, so if I run this, we should be seeing 600 rectangles about the place. Okay, so we saw this problem in class before. The function random, which is going to return a value, so that's why we're able to assign it to a variable, is going to return a value that's a float, and we've told our x and our y values to be integers. So we've got this kind of wrong shape of box problem. So the simplest solution here is to just change your x and y values to floats. Different shape of box, different type of variable. And this should work now. Okay, cool. So this is a really simple example of showing you how a fixed for loop can be used to generate a pattern. And something we can see here that's kind of fun, there's a real sense of depth because things are drawn on top of each other depending on when they were drawn within the for loop. Okay. So simply put, we've got our keyword to tell us what we're doing. We have a counter inside our for loop, which is just a variable. This is separated with a semicolon. The bit in the middle tells us how long this is going to happen. What is the condition? Well, we want this for loop to iterate, and this is, well, the counter is less than width in this case. And in the final part of our for loop, inside the regular brackets, is the bit where we increment the counter. And we can do this using just ++ and go in steps of 1, or we could go back and use plus equals and change this to something else. So now our for loop will go up in jumps of 10 rather than 1. Everything that happens inside the curly brackets is going to be part of the loop. That's what's going to be iterated over. So this will happen for while I is less than width, and I will be jumped up in steps of 10. So this time we'll get considerably less rectangles. Okay. Okay, hopefully that sheds some light on for loops. Thank you for listening.